Good morning, ladies and gentlemen. This is Mr. Rode. This is Geometry Part B. This is Lesson 8, and we're going to look at how to find the area of a sector. Now, remember that a sector is a portion of a circle. Remember, arc length was the distance around the circle, the part that you're walking around. This is the area inside the circle that we're looking for. So a sector, like this would be a sector right here, this blue region. And so how do you find the area of a region? Well, it's real simple. We're going to take the area formula and we're going to multiply it by the portion of the circle we're talking about. So here is the area of a sector formula. We have the measure of the arc that we're looking at. So the arc of the sector that we're talking about over 360. And this is times pi r squared. Now again, remember, unless you're told otherwise, you're just going to leave the answer with pi in it. You're not going to do any kind of estimation, 3.14, 22 over 7. Just leave it as it is unless you're told otherwise. So right here, this one's real simple. We got 160 as our central angle. So that's the measure of our arc. We got 160 divided by 360 times pi times the radius, which is 9. Squared. Now this is where you want to pull out your calculator. Don't try to do this without the calculator. I mean, you can, but don't make a mistake by not just simply typing some stuff into a calculator. So here's our calculator. And we're going to go in this order. We're going to do 9 squared because that's the exponent. So 9 squared times the numerator. And then divide by the denominator. And there you go. We got 36. And then don't forget pi. So our area here is 36 pi centimeters squared. So that's all there is to this. All right, let's take a look at our next example. So this time we have our sector. It's this big major sector. But we're given the minor arc length. So what do? We have to take 360 here. We have to subtract 120. So that gives us 240. That's going to be our arc length for the sector we're talking about. And so we're going to go to our formula. Measure of the arc divided by 360 times pi times the radius squared. So our arc is 240 divided by 360 times pi times the radius. Our radius in this case is 21. And so that's squared, just like the last problem. We're going to start with the exponent, 21 squared. Make sure you hit enter. Times the numerator divided by the denominator. And there you go. We got 294 pi, because we haven't used an estimate for pi. And this will be centimeters squared. Final answer. Real simple. So the only change here was that we had to find the arc of the sector we were interested in instead of using the sector that was given. All right, last one. This is kind of similar to one you're going to see. It looks a little bit confusing, but it's really the same process. If this is 35 degrees right here, well, guess what? These are vertical angles right here. So this is also going to be 35 degrees. So we're going to use the arc addition postulate to help us figure out the arc that we're looking at. So the measure of the arc that we're dealing with will be 35 plus 35, which will give us 70. So that's going to be the arc length or the arc measure that we're going to use for our calculation. So again, the measure of the arc divided by 360 times pi times the radius squared. We just figured out that the arc measure that we're going to use is 70 times pi, and we're given that our radius is 18. And so now again, this is just a calculator problem. So 18 squared. Hit enter. You don't have to, but just go ahead and do that. Times the numerator divided by the denominator. And so that arc length, or that sector measure is 63 pi meters squared. So I hope this helps you with the area of a sector. If you still struggle with these as you're doing your assignment, please let me know in a teacher message for a help session.